Hi, I'm pleased to be joined today by Mark Thornley of High Peak Steels. Mark has been managing director of the business for almost 40 years when he and his wife Anne created the company. Today they have a head office facility in Glossop near Manchester and secondary warehousing nearby, as well as some engineering stock which they keep at ports in the UK and bring up to head office when required. Mark, good morning.
Morning to you, John.
I want to focus today on a specific engineering grade that you've been talking to me about, EN8. Can you tell me, Mark, why is EN8 so popular with your customers?
Sure. Well, EN8, also commonly known as 082M40 or C45, it's commonly used or commonly known as a medium carbon steel, whereas mild steel is a 20 carbon steel. It can be supplied in bright drawn condition. It can be supplied as black bar in the as rolled or normalized condition. We stock 6 mil up to 800 mil diameter, normally on the shelf and ready to be supplied in random lengths or cut pieces. There's not a lot of difference in price between mild and EN8. Therefore, engineers prefer the better properties they can get with EN8 and they don't have to pay a whole lot more.
Okay, great. Now, you just nicely led into properties there. Can you tell me a little bit more about the properties of the grades? Because I know this is very important to engineers.
Sure. So it's a medium carbon, normally 0.4 to 0.45%. It has about 40 tons tensile. It machines well. It can be heat treated. It can be flame or induction hardened. It's suitable for most general engineering applications requiring a higher strength than mild steel. It's preferred for being able to offer a higher tensile strength in requirements like, the finished product being an axle, a gear, a shaft, or anything that needs sort of reasonable wearability.
Okay. Now, engineers are always looking for a deal. So can you tell me, is it more expensive compared with other material grades?
It's actually great value in comparison to your alloy engineering steels, probably 50% cheaper, but still produces a good tensile strength along with good wearability. So it's become one of the most popular grades to use for economic reasons.
Right. Okay. Very good. That's a significant saving potentially there for engineers. In terms of the industry applications, can you tell me the engineers that you're working with in terms of their sectors and
Sure.
what sort of typical grades are then used for?
Yeah, so EN8, it can be used in construction industry, be used for buildings, bridges, and heavy duty equipment. In the oil and gas industry, it'd be used for parts like, in bits and pieces or machine parts in pressure vessels. In the automation and heavy machinery, it'll be used for gears, for shafts, for axles, as we've explained, for excavation arms in the likes of JCBs. We sell a lot into the yellow goods market. It can also be used for things like crane booms.
Interesting. And can you heat treat the material? And if you can, what context would you need to heat treat the material for? Because it's obviously got good case hardening in any case.
Sure. So normally, you can anneal the EN8, you can flame harden it or heat treat it to obtain a desired tensile strength and hardness. Most of the EN8 we supply will come in the as drawn state if it's bright bar. If it's black bar, then it's either as rolled or normalized condition. The reason for heat treatment would be to sort of refine the microstructure or harden the material to obtain the required yield or elongation or yield strength that you need. So by heat treating it, you refine the material, you then get a material with fewer hard spots, so it's easier to machine, which helps save cost. A lot of customers will buy the material in a softened state, i.e. normalized. They will pre-machine the part and then they'll send it for hardening or heat treatment before they finish machining the components. This reduces the machining costs by working on the softer material before they send it for heat treatment and then eventually completion.
And Mark, I understand from things you've told me before that has an economic impact for the engineers because they're machining faster because the material's not hard. And also, didn't you say that their tools will last longer as well?
Yeah, sure. Well, sure. In the anneal state or the normalized state, obviously they get if they're able to machine it easier than its toughened state or heat treated state. So it does save money, and that's why they take a lot of the weight out of the material. They also pay heat treatment people on the cost, like a cost per ton. So it depends on the weight that they send to the heat treatment place. They get charged by the weight that they send into the heat treatment people.
Right. Can you tell me any more about the wear resistance, or have I extracted all the information from you already?
No, Jonathan, it's got good wearability. You get a low cost material that has good machinability. You can heat treat it. It's got a decent tensile strength. We've got a great size range and availability. It doesn't wear out easily. So a very good practical choice for a lot of different applications.
Remind me of those sizes again. You said something to 800. Can you tell me that again?
So we do, yeah. So size range, we do in round bar, we'll do in black round 25mm diameter up to 800 diameter in black. And again, we can supply that in cut pieces or full length bars. In bright bar, we stock as small as 6mm diameter and go up to 200mm diameter in bright bar, both in metric and imperial sizes. We stock flats and squares, mainly in bright condition, but we have a limited size range available there. We do stock EN8 as a key steel. So as well as that's used mainly for the driving torque between couplings, for gears, for sprockets, and can also be used for moving shafts and pulleys, you know, and even down to propellers. So that's the EN8 key steel that we do. And again, good size range, and again, available from stock.
Tremendous. Now, Mark, I've had the privilege of coming to your facility on several occasions and seeing the tremendous workflow that you guys have, and obviously with your own fleet there. One of the things it's worth saying about High Peak Steels is your ability to deliver on time and in full, and the stats for that are just quite remarkable in the industry of 98% on time and in full. Mark, it was really great to get your insights today. So next time we speak, we're going to do another one of these videos, and we're going to talk a little bit more about S355. So please watch out for this in a few weeks, and we'll explore more about the engineering grades. I'm Jonathan Rayfield, talking to Mark Thornley of High Peak Steels. Mark, it's been a real pleasure today. Thank you for your time.
Thank you, Jonathan. Speak to you all soon.
Bye-bye.
Bye now. Bye.